two classification algorithms will be discussed in this class. Last class, what algorithms have we looked at for classification? Can anyone remember? Or can anyone?
The priority, the decision tree?
Decision tree, right, decision tree, based upon Bayesian algorithm, which means decision tree needs to be constructed first. Basically, decision tree, the node, each node will be a column of a table, and the link in the tree from the parent node to the child node, there's some conditional statements, right? For example, if we choose age as a node, then the edge to the node below, there's a decision by saying age is greater than 10, or greater than 15, or 30, something like that. So once we construct a decision tree for the training data sets, the next time when we have real data, then we can simply apply that, right, according to that decision tree. So once we have a good decision tree, then we'll have very fast and very good classification. Another way that we need to do the classification is k nearest neighbor algorithm. What do you mean by that is, see here, we have quite a few students in this class. If I ask you to group among yourselves, of course you did for your group projects, then for your group project, you probably bind together based upon some distance between you and your group member. So distance can be measured by the interest. If two members have the same interest, then they can be in the same group, highly likely, right? If there are any two people having the totally different areas of their interest, for example, one student wants to do the classification of intrusion attack, another student is interested in forensic investigation, then they have some distance between the area of their interest, right? That distance is not the same as, for example, one student's interested in association rule mining, another student's interested in Bayesian rule mining, then both are the algorithms in data mining, so the distance between those two data mining algorithms is shorter than one data mining algorithm, distance from one data mining algorithm to forensic investigation tool, right? Those are two different. So as far as we have this accurate distance function, then we can apply this k nearest neighbor algorithm. What do you mean by k? K means a new example is assigned to most common class among k examples that are most similar to that. K means algorithm, and so therefore we first decide, each group needs to be at most 4 members. Then they want to find out the closest 4 members. There is a k nearest algorithm. Okay, so k is nothing but a number. integer. Okay. So to determine the class of a new example E, we need to first calculate the distance between E and all example in the training sets. For example, okay. Oops. Back up. No. Too much. Okay. So this is me. Okay. I'm here. So I want to recruit my class, my group members. Then I need to consider each one of the students so that I can measure the distance. And according to my measurement, I can think, oh, those three are the closer to me than the other two, so that I'm going to recruit them in my group. That's very clear, right? So you apply that idea when you try to meet somebody all the time. So, what is the distance function? So typical distance function is this. If we have two-dimensional data, in this case, there's the distance between x and y. Okay, two objects. Okay, each object can be described by n features. Okay, so y also has n features. Each feature can be any attributes that may describe about you. For example, your name, age, major in graduate, major in undergraduate, major, not major, GPA in high school, or types of math taken at the high school level. Each one of those will be a feature, so that the description of you will be n number of features. N number of features. When we compare, for example, two people, x and y, then we need to take one feature from each. If it is age, for example, so age of x, age of y, right? Of course, the description of x and y should be in the same format. So x1, if it is the value for age, then y1 also. So we make the difference. Okay. But if we simply subtract, then sometimes we may have negative value. If we have one positive value and another negative value, if we add them together, then maybe cancelled out. So that there's no difference, which means they are exactly the same. So they may be misleading. To avoid such a misleading measurement, what we need to do is to square them. Okay? Although square, it is not accurate distance. but it preserves the difference. Because there is no order between x and y, so we cannot compare, we cannot subtract from, smaller from bigger one. Arbitrary true objects, therefore we may have negative value, but negative doesn't mean much here, but the magnitude of that negative value, that is important to preserve the magnitude of the subtraction. We need to square those values and add them all, and finally we make square roots. Then this square and the square root and this square will be cancelled, right? Eventually. So we will have the accurate distance. It is called Euclidean. So one of very, very famous mathematician, French mathematician. Typically French mathematicians are so great, right? When was it? At least 2,000 years ago, or sometimes 3,000 years ago. There are great French mathematicians. They developed a lot of, I'm not sure Euclidean is French, but in general, right? Why?
Sounds like a general statement. All right.
Oh, we're trying to make a classification. So that is a classification. Alright, so that is that. So example apply this Euclidean distance to these two guys. John and Rahel. And we compare each features to make the distance. So 35 and 41, 35 years old and 41 years old. So let's try, this is, I want to subtract Rahel from John. So John, 35 minus 41, then that is negative value. To preserve negative value, I need to make square here. Right. Again, the income, 95K and 20, wow. 215K. There's another negative here. So these two features, this lady is bigger than this guy. What about the other ones? Number of credit cards. Oh, this guy loves credit cards. 3 credit cards, and this lady has 2 credit cards.
She make her own credit card.
So 3 minus 2, then that is 1. How many credit cards do you have even?
Me? I got 2.
Oh, so you are in the group of richest guy.
Alright. I'll take that route.
I have 4. So, oh my God, I'm outside.
You're past John. I have 0.
You are the richest, top 1%. Top 1%, they do not need a credit card, right?
Well, no, because you want a credit card to build credit. Yeah.
No, they don't need to carry credit cards.
They don't need to carry them.
Right. They have secretaries. Hey, charge it to.
Yeah. What they do is they buy something they can pay off immediately. Yeah.
Exactly. Yeah.
Well, like Porsche, put down $95,000.
Yeah. I've heard. There are some. Yeah. Here, for example, in Irvington, a huge home like a castle. The price of such a castle is for example, 20 million. Or 30 million, 20 million or 30 million. It's not 2 million, 20 or 30 million. Yeah, that's it. So I was asking one of the bankers that I know. So I said, how much do they loan? They said they never loan. they pay off. How come they loan, for example, $30 million? If they loan half, 50%, still big down pay, right? Big debit, still big debits, right? So they don't do that. Amazing. But anyway, this is how you calculate K nearest neighbor classification, okay? So idea is very, very simple. So there is no model assumed. You simply calculate and make. This is an example. If you want to make a 3 nearest neighbor, among those, we have John, Rahel, Hannah, Tom, Nellie, David, all different ages, different income. Oh, right. Rahel's income changes from 215K to 50K. Number of credits and response, yes, no, whatever. Okay. Response in this case, there's a label of a class. So according to the distance function, yes means can be in, there's a nearer to some caller. Maybe caller is this, David. David says, who will be, who are closer to me? So Rahel and Nellie and David, eventually. Okay, so we need to calculate distance from David. Okay, so David is the caller. Okay, so this guy needs to, David is a pivot. Okay, so who can be closer to David? That is the question, right? Can we pick the best 2 more, including, so 3 all, including David? That is the question. So need to compare David with John, David with Rahel, and each person here. So this is a calculation. Okay, each one of this. So one of the calculation here is that, for example, Hannah, then square root, because we need to do square at each difference, and then we need to add them. First 63 minus 37, that is AG. And then next one is 200 minus 50, that is the income. And then finally, number of credit cards. So the distance is this. And another distance is that. So having those distance, we can say, we can calculate, we can make decision, okay? Very simple, right? K nearest algorithm approach to classification is simple. For example, if you want to do a group project to classify given data sets, then, and also if you want to practice programming in Python, this is simple to make. Okay. Another simple is decision tree, and the other one that I love that. Hopefully, so do you all. It's deep learning. Have you heard of deep learning algorithm? Raise your hand if you have heard of deep learning. Deep learning algorithm. I think, was it early this year in spring? Or late, about a year ago? There is a Chinese chess called Go. Is it Go?
Yeah.
Go, right? Go, the world champion, it's not really a current world champion, but one of the world champions who became world champion, I think, at least 5 times. So one of Korean guy played with artificial
Intelligence?
Go. Yeah, intelligent. The built by one of scientists, so originally from Singapore, right? In London base, but he studied all his education in London. He founded a company. That company uses deep learning algorithm and to predict and make quick decision. And that company was acquired by Google. So finally, Google and Google products, okay, which is a program, compete against the human player. So who won? Finally, anybody heard that? Human lost. They played 5 times. Human defeated only 1 time.
Oh, the first time, right?
No, third or 4th time.
Yeah.
4th time.
Because of
Yeah, first 3 times lost, defeated, and then 4th place, I think he defeated the software, and finally he was defeated again. Somebody said that player, human player, think alone on that play. The software, how many people built that software? Hundreds of people built the software. For how long? For many years. How many computers are running behind that software? The Google set up, I think, 100 servers. So, that much computing power, if we have that much computing power, then the Go game is not simple. It's very, very difficult. Can you play Go game? Would you be able to explain? Or here, do you play Go game? No, you don't. Anybody here can play Go?
I don't even know what's a Go game.
Go,
It's like
it's a
like
star-shaped board. It's basically chess and checkers.
yeah, chess.
I know chess.
Yeah, it's like the board. Hold on, let me.
Why don't you pull up the webpage? Pull up.
Hold on.
Escape. You escape.
There are 19 grid
Yeah.
each,
It's one
so we have 19.
difficult game in the world.
19.
Yeah, it's like
So how many how many how many ways that we can move given sets of movement? How many ways that we can move for the very next time? They said millions, right? So considering all such millions, it's almost impossible in human brain. But computer can do. Right? Computer can do. So the guy, human player, confessed after the game. He thought there was a couple of ridiculous movement. But eventually, that was the right movement. Because of that ridiculous movement, he was defeated. Why that happens? Because humans, they have their own heuristics. Because the human learned it from another human, which learned from another human. So there is somehow built-in heuristics. So human cannot think that movement never ever before. But computer programs scan through all possible, never skip any. Therefore, he can make some ridiculous movement to human eyes. You have some comments?
I was just saying that that could kind of tie into something I was researching lately on text singularity. It's like technology or computers that can kind of get better, improve themselves as they go on.
Yeah. So what we will do today?
Self-improving.
Yeah. What we will do today? We'll do a little bit of that one. Okay. So you will be surprised.
Okay.
Coding list in the slide. But I will explain it. Without explanation, it's very hard to understand. But before we get to that, oops, not this. Yeah. Okay, this card. And another. Okay. Before we get to that artificial neural network, I know some of you also came to me and asked questions about your projects. Who did that? Yeah. Talk about intrusion, some attack classification, and then predict attack quick. So you may. Not you? Or Ellen?
He asked you a question. But
somebody stopped by me and asked questions about. So I talked to that person. I don't remember because I have so many students to come. So I talked. We need to learn time series data. Confess if you heard that from me. Nobody? Nobody in this class? You?
Go
You raise your hand? No?
No.
You pull down the ears. Maybe? Okay. Oops, not this. Alright. So what is time series data? I'm going to explain to you very quick time series data, and then we will jump to neural network. Okay? And then we will do programs, very, very simple programs, which is in Python. Okay? Very, very simple. What I want you to do is that you can practice and improve that neural network and do some great work and prepare for that work, prepare the work and improve your work from the work that I provide to you today and also explained it to prepare for NSA presentation. NSA guy will come December 8th and 9th. So those who wants to join NSA, please seriously prepare for something. Okay. So you will have a highly likely great chance if you apply this artificial neural network built on your own by yourself. But don't forget me when you become director of NSA in next 15 years. Who knows, right? Who knows? Will be a director of NSA. Okay, so time series data. The time series data is a collection of observations made sequentially in time. Sequentially in time. For example, Hillary Clinton's popularity rating. It's a time series, right? Similar to Trump, but I skip him. And blood pressure. So time series, right? In the morning, I have a high blood. Is it true? Morning high blood or evening high blood? Blood pressure. Evening high blood pressure. Okay.
I think it's afternoon, while you've been awake.
Okay. Somehow blood pressure
Well, you don't have blood pressure.
changes.
No, you do have blood pressure, but it's lower.
I mean, yeah.
Because it's a but when you're going to sleep, it also drops because when you're going to sleep, it has to kind of coax you into it. So the low, it raises just a little bit when you wake up, and then it's at the afternoon while you've been awake. That's why you feel most energetic around noon.
Well, depends what you do when you
No, it's talking about in general,
blood pressure.
right?
Listen, what you do on the internet is your own business, all right?
Not
So annual rainfall in New York, a value of their Yahoo stock price, a number of web hits per second depending upon time, right? So everything, all the data that we consider, and also we think interesting is time series data. Therefore, any patterns that you eventually can describe will be related with time. Somebody said, oh, this kind of pairs may be very dangerous or will be a malicious attack software, but it's not always malicious, right? But it may be more malicious if they bind together, for example, 2 o'clock in the morning rather than 2 o'clock in the afternoon. Time series data can be collected in many ways. For example, human body heartbeat or brain, like EEG data. Or nose, mouth, whatever. So anything that's sensitive, any data that if that is sensitive and interesting, then there are a time series data. Of course, when it comes to time series data, we will work on R. R Studio has very, very useful tools already built and available for you to use, rather than implement on our own. So we're going to use it. So a lot of techniques. There's a cardio. This one is like a heart. If you learn sensor network, then you can. We'll discuss about all of this. What do you mean by R? This is a pattern. All of our hearts has this PQRST patterns. But have you heard of that test, so that you have a printout those that are RTR, PQRST type of things? So usually they don't show to you, assuming that patients do not understand. But if you learn sensor network, for example, KGG or KGG? EKG, right? EKG or ECG. Then that's normal. And if you have any shape away from that normal shape, then you might have some issue. That's what they do. But usually, when you took that test and there's a printout, and the examiner, if I ask, because I know a little bit, so what do you think? Am I good? And she looked at, no, I cannot tell you. I cannot tell you because my doctor has all authorities. But can I see that? Okay, I'm okay. And the implementation of that is only not more than 100. But if you test that, one-time test, I think a couple of $1,000. Not couple of, about $1,000. Okay, so you can make it and test it every other seconds. So you earn how much money? $1,000 every other second. A lot of such things available. Oops, not this. All right. So you have somehow time series data. Think about time series data like blue lines and red lines, right? How can you compare two different time series data? Both are over the same time period. Same time period. For example, you have here and there's a time. You have time here. And some of the magnitude. Whatever the magnitude that is. Okay, if there is EKG, then maybe this is Q, R, S, whatever the values. Okay, so one time you have this, another time you have that. Currently, it can be diagnosed by human. So human take a look, okay, medical doctor take a look and then tell you some, right? But if we need to do that by software needs to compare how your data mining tool compare those two. The idea is very simple. At time t1, there's 2 points, right? So make distance, qi minus ci. And next time points. So you have 2 values. Euclidean distance can be computed throughout all time period. And then you can see, hey, these 2 time series data are similar to the other pairs. You can tell them, right? You can tell like that. This is a very, very typical and naive approach of time series data comparison or grouping. Another way that you could do is there any way that we can summarize, so-called summarize? When you read the articles, then you can summarize it, right? The summary that you can make reflects the detailed description, right? In the time series data, similarly, this is a given data. This is a given data. But if you make this red line is a summary of your detailed time series data points. Okay? We call that approximation. How do you make approximation? That is the issue. So that this guy is similar to that. Or this guy is similar. This guy represented in this way. This guy represented in that way. If we compare these 2 data sets, Q and S, quite different. But after this approximation, if we compare, this is approximated lines. If we compare these 2, instead of a comparison of the raw data, if we compare this approximated data, then it gives us at least 2 benefit. it can give very clear computation, right? So approximation, although it is not really real data, but it's clear computation. And also fast. Let's say this is the data points for each points is a day, points representing a day, daily data. So this is, let's say, 3-year data. If we approximate that, then we have how many data points? 1, 2, 3, 4, maybe 4 or 5 data points. We can simplify that from thousands data points to 5 data points. So very clear representation, number one. Number two, therefore, fast computation. If we compute this in this way, then it takes so long, but in this case, very quick. Only 5 data points will be compared. Questions so far? Okay. So with this in mind, I'm going to jump to neural network. Neural network. Reason I'm putting these slides earlier, right before Thanksgiving break, I wanted to take this algorithm to improve your work during Thanksgiving holidays over 2 or 3 turkey meats, gravies, and all kinds of food, cranberry juice. Don't drink alcohol. If you drink, sleep.
That's not the fun.
Somebody said, I'm good at driving. Only if I am drunk.
I had a guy that couldn't work as later until he had a few drinks in him. If he was sober, he was terrible, he was nervous, always forgetting things. And I swear you give this guy 3 double martinis, he'd be bouncing around table to table, perfect service.
Yeah.
It was bad, but it worked.
The customers like him, probably.
Yep, yes they did.
Especially the airplane pilots, their driving is so terrible. Yeah.
Airplane cops.
Yeah. The longer that you drive, operates airplanes, the worse the road driving patterns
When they're flying
become.
planes, they're going how much faster when you're driving a car? So
They want to tilt up your dashboard. Okay, what are the neural network? Neural, you understand what neural means, right? You may understand better than me. So models of a brain and a nervous system. The brain system. Highly parallel, process information much more like the brain than a serial computer. It can learn, and the idea is very simple. So simple principles, but it behaves complicated. Complex behavior, but simple principle. This type of, the great detail of this type of lecture will be given in the fall semester 2017 for undergraduate students. There's a class called Secure and Intelligent Programming. Applications as powerful problem solvers, as biological models, but you do not need to know biology. Me neither. To challenge you, pigeons as an art expert, this is real experiments, and published in 1995. Pigeon is not really an artist, right? Pigeon is a bird, but pigeon has a brain, right? We're not talking about any animal with no brain, but brain. There's some brain. Experiments conducted in this way. Pigeon is in a box and present paintings. In this particular experiments, two paints, one by Chagall and another one by Van Gogh. You all know, right? For example, whose paint is this? Chagall or Van Gogh? Van Gogh. This? Chagall, right? Both had painted in France. Chagall is not French. Chagall is, I think he's Belgium, right? Originally? Belgium? Van Gogh. A few years ago, I visited the place where Van Gogh spent the last 72 or 75 days of his life. So he died there. But anyway, this is pigeon, and then and show pairs of those two paints, and then give some rewards if the pigeon presents. Show this with some reward, and with some others, no reward. We can. What is it? What is the process of that? It's like a training, right? Like dog animal training, they usually train with some rewards, right? Have you trained your doggies, cats, snakes? Particularly doggies. I've done that a couple of times in my life. Doggies are following human very well, right? Why? The lesson that I learned was that doggies' concern is not us human. Not all the dogs, but some dogs that I raised. That guys do not care me or my family, but he cares much the food. As far as I provide the food, it follows. So when I provide the food, it follows. And when I run, it still follows. But when I drop food, he stopped and eat the food until swallow the food. He doesn't follow me. But immediately after swallow, then continue to follow me. That is some of the experiments, right? So reward is very, very important. Same thing to here in these experiments. So what is the thing? Pigeon were able to discriminate between Bengal and Chagall with the 95% accuracy with the training. So training needs to be done. How many times of a training? I don't know, but depending upon their the level of intelligence, right? What about neural network, the software that we learn today? How many times should we train? It also depends, but if we train 10 times, compared that with trained 60,000 times, then at the end, 60 times of the training will perform much better than 10 times only. So this guy may learn from animal training. And can we do the same training to the software? That is their idea. And they implemented that. How? Like this. ANN means artificial neural network. Artificial neural networks incorporates the two fundamental components of biological neural nets. It has two components, neurons and synapses. Neurons and synapses. Neurons can be represented as nodes. Look at this. This is like a network, right? Nodes. And then synapses. Synapses is like one neuron pass data to next neuron, pass through some linkage. So linking is nothing but snaps, and that is the link. And each link has weight. So in our programming, synapses can be represented as weights, and neurons as nodes. So you have nodes, the circles nodes, and weights, that is the label to the linkages. Each edge or link has weight. In neural network, weight needs to be calculated continually, differently, randomly. If we use very good weights, then that may learn very quickly. But if we do that manually, then it may work for the problem 1 well, but may not work for problem 2 or 3 or 4. So it should be very general. So what we will do here is weight, the calculation of a weight should be arbitrarily and continually, repeatedly, at every time, might have different weights. In biology, we have cell. Cell has nucleus inside. There's a neuron, right? We call this neuron. That is connected to other neurons and others, right? So there's some data flow. For example, if we have a neuron here, okay, if we have a neuron here, we call them node. There's the input data to neuron. Like we have here cell, then there's the input data from here From there, some input data, right? Some input data. And there is some output from there to here, right? Some output. So internally, there's some operation, some calculation needs to be done. That's what we need to learn. That is the thing that we implement. So structure of a node is that there is an incoming edge and outgoing edge. And there's a squash, we call it squash, in some limited boundaries. So we map some number, given some numbers here, so that we can say, oh, this is almost 1. And some numbers, oh, this is almost 0. Right? So this function returns, in this case, 0 or 1, right? Somewhere here. Some other functions may return -1 to +1. So depending upon the functions to choose, we might have different performance of a neural network. So another beauty, then you need to practice. So when you train the given data sets, so you can train it, for example, 100 times, oh, you have good result. Or with other functions, you may have that similar outcome by 100,000 times training. So different performance. Okay, there's no absolute solutions available. The same thing in our human brain thinking process, right? Not all people have the same performance. Even the same person, you do not make the same decision or similar decision to the similar stimulus, right? Sometimes you don't do, sometimes you do. Similarly, here. And also we have weight. We can give some weight. For simplicity, we try to generate the weights, not just the simplicity, to make it normalized. Normalization. Then this weight should be in this range, -1 and 1. In that way, that weights can be used for other situations. It's normalized. Any number, it should be dropped into that scale. So, let's say you have consider this, our practice. After we do this practice, I'll give you some simple example. By learning that simple example, you may say, oh, this guy predict something. Think about exclusive OR operation. This is operation, right? Exclusive OR operation. Then we know the rule. Exclusive OR operations returns 1 if those two values are different. Otherwise, returns 0, right? So 0 XOR 0 returns 0. 0 XOR 1 returns 1 because they are different. 1 XOR 0 returns 1. 1 XOR returns 1. That is 0, right? So can you train with that? That's what we want to do, right? So if you see this, then there's two input values, right? Two input values. We can say input value 1 and input value 2. So from external, we can provide the data, says 0 or 1, right? And then we have output. Here, this is output. In this simple example, we have 2 inputs and 1 output. But in real neural network, may have a multiple input and multiple outputs. Fine. And between this input and output, there's some long process. In other words, they have other nodes and other links and another nodes and another links and another nodes and another links. If we have more depth, of neurons and linkages, we call that deep learning. This is deep learning. Okay. If you do not have such a learning mechanism, we don't call it the learning, right? For example, when you do decision tree or k-nearest neighbor algorithms, then there is an algorithmic approach. You can expect, this will return. Given this data, then you can expect to have the outcome, because there is an algorithmic approach, right? But not in this case in neural network. We do not expect what kind of outcomes that we may end up having, right? How artificial neural network learn facial similarity. This is an application, right? If you have a neural network, then you can also classify the faces. So when you pass through the airport screening systems, and if TSA guys has a list of the faces to be wanted, but humans cannot recognize you as a terrorist. No, bad example. But computer can recognize very quick, right? According to that. So we have a bunch of already known terrorist face. So we train our neural network with the complete set of the terrorist. And with that, next time, if we apply that neural network to test data, then neural network probably pick, this guy has 95% potential terrorist. This guy is 25%. This guy has 43%, and things like that. Okay, that is a neural network deep learning process. Similarly, like face recognition, we can also ask to artificial neural network to recognize a cyber attack. Not just the face, but looking at the sequence of human behavior, then this neural network think, oh, this is highly likely potential attack by looking at the behaviors. In order to do that, we need to have test data. With the test data, we need to train the neural networks. Possible, right? Similarly, if our neural network well trained with the stock price, trend of stock price, if there is no abnormal disaster or crisis, then it can predict very well the price of the next day, the very next day, because this guy knows already and trained well till today. If there is no abnormal crisis tomorrow, then the stock price moves slowly, so that this guy can predict well. So a lot of examples possible. So you can tweak, if you want, your projects during Thanksgiving holiday, not only eating turkeys, but recognize turkey face. Question?
Professor, what is SVM mean in this picture?
SVM is
Support
support the vector machine.
I know this. It's
Oh, you know that?
Algorithm.
Mm-hmm. Yeah, support vector machine.
It can using, AI or it's totally different.
Right, it's not right. We're not going to do this, but artificial neural network in this class.
So
SVM is a good tool for classification, for example. Okay, if you have training sets and next time if similar data comes in, then you can tell, oh, this guy should be in this class.
And you put SVM in here as
No, not in here.
Is
That's
it
a specific
SVM
example.
as a deep learning?
Maybe not. No? I'm not sure. Yeah. Okay. I think we need to take a 15-minute break, and when we come back, we'll do real programming, okay? Rather than, well, hold on just a second. Let me explain this, the real work that we done. Okay. Let me explain this, and then we can take a break. Okay. In our example here, okay, what we will do is, artificial neural network has two major steps: training step and testing steps. Testing, which means we're going to use it. The training data sets that we are going to handle is the same problem, exclusive OR operations. So that given this, then how much is it really true if we train them? For example, 0 and 0, two exclusive OR operator, then what is the result? Should be 0, right? But if we say 1, this is a training sets, then what happens? If we train this guy like thousand times, this guy says, oh, it's not 0, it is not 1, it's close to 0. If it returns that, then that is the learning, right? Similarly, for this guy, this is a list, right? This is begin of that list, this is end of that list. Inside, we have multiple arrays. Okay, each array has 3 elements. This is input, this is, actually this is input, and we call this some bias. It's not really outcome, bias. This operator has been biased by 1. It's not really true, right? But biased. So given 1 and 0 and 0, this particular tuple, particular case, biased to 1. 0 and 1 biased to 0, which is correct. 1 and 0, oh no, this is also wrong, right? This is biased. This is also biased, but this is correct. This guy biased, that is wrong. This guy biased, but that is correct. This is correct, and this is correct so far. This is correct, and this is correct. So in the training sets, we have, this is a real training set, right? Some input data and biased. As we train, we need to provide the outcome. Hey, by the way, the first one should be here. First one should be 0. This is our outcome. This is our expected outcome. This guy should be 0. This guy should be 1. This guy should be 1. This guy should be 0, 0, 0, 1, and 1. This is a real outcome. Okay, this is training sets. What we will see here is that will these guys eventually, instead of 1, close to 0, this guy close to 1, this guy close to 1, and things like that. Okay? There's a learning. This detailed technique. This is the input data, training data set. This is ideal output. This is ideal output. I give ideal, okay? And to see if multiple iteration of whatever the computation, that value should close to that ideal case. By doing that, it is trained. But this is an array of let's say you can think of a 2-dimensional array, right? So this input 1, input 2, and bias all together the first element, first row, second row, third, fourth. We have 1, 2, 3, 4, 5, 6, 7 rows. Outcome, ideal output, we also need to have 7 rows. But for programming purpose, if you do not want to make this long list, but you can hard code like this. This is the beauty of Python. Simply at the end, if you put .t stands for transpose, this will be changed to this format. So you don't need to type this, but simply give this. So we'll practice that a little bit. And we have a node and edge. Node is nothing but neuron, edge, snaps. And we have input and output, neuron and hidden neurons. Somewhere here, we have input, 2 inputs, and 1 bias. This is input, 2 input, 1 output. Internally, all is added. All are added. We have a hidden nodes. We have a bias. At each level, we have a bias. Bias 0, bias 2, bias 3, 4, 5. They work together. And each snaps, we have a weight. Weight 1, weight 2. And bias also has snaps. usually this guy has some value because this is given, and bias we have only 1. Usually give 1 as a bias, but in our case we didn't give all 1, but that's okay, right? Anyway, that is bias. You can do that too also to verify all 1s. So initially we can give, hey, they all return 1. So see if they really trained, therefore prone to the correct outcomes, ideal outcomes. That's what we want to see. We have synaptic weights. Here's what we do. Weights should be, for our program, for simplicity, in this range. And activation function, there are many ways, many different functions available. For example, if we have this neural network is not really deep learning because we do not have any hidden nodes. Simply we have input directly to output with the wages. Then output will be in this way. Output will be the input value times weights from the node 1 to the nodes. And finally, if we have bias, but then we have weight for that, bias usually have the weight 1, right? Or 0. So that add them all, and this is actually, you can call it activation. Activation based on function. Sigmoid function or hyperbolic tangent function or the function that you may develop. Okay, the typical known function is a sigmoid here. This is a function. Take the value x. It is 1 over 1 plus natural base to the power minus x. And if we apply this, if given x, what is x? Entire this is x, right? This is x. So given that x, apply that here, then it returns. This is very nice. It returns somewhere between 1 and 0. Or depending upon the function, if you use hyperbolic tangent, then it will return somewhere between -1 and 1. Okay? Then it is shaped like this, in 3-dimensional. So you have a multiple calculation. This is snaps, like wedges, can be calculated in this way. This is the module, numpy module. NP is a numpy in Python. Numpy module. You have to import that. It has a random function. Okay. This random function can take the structure of data. 3, 1 means 3 rows and 1 column of random data. 3 rows and 1 column random data. And then we multiply that by 2 and finally subtract it 1 y. I wanted to think why, but I already explained why, but I'll tell you why. This is a little programming skill. Okay, so we'll take 15-minute break. Come back. Oh, already. So we'll practice this. Okay. Oh, the question: why we multiply 2 here and at the end subtract 1? Can anyone say why? Edmund? Any idea? The formula is not fixed and it's not given. Can produce like that for any purpose. You can modify it. So you need to understand why that generates this kind of random number, and it gives 3 rows in one list. That is 3 row, comma 1. Okay, I explained that. So first one will be W1, second one is W2, third one is weight 3, because we have 3 nodes from upstairs, 2 taken from the input data and 1 is the bias node. Anybody in any language has generated a random number? Probably you did.
I think I did in C++ back in C++.
Right, then you probably know. Usually random numbers, if you don't do any, it returns any numbers between 0 and 1, but exclusively. So 1 is not returned, maybe 1. Doesn't really matter, yeah. So from any number between 0 and 1, that is the function random can return. Okay? But if you want to make this random number, what is the random number that I want to have in our program? It's greater than or equal to -1 and less than or equal to +1, right? That is what I want to have. So in order to generate any number between -1 and 1, in the case, the random number itself returns a number between 0 and 1, then you need to manipulate it. You need to multiply these 2 so that it will be 0 and 2, right? Any number between 0 and 2. And if you subtract that by 1, then it returns -1 to 1, which is this case. Understand? Edmund, do you understand?
Trying to.
Alan, do you understand? Alan, why you don't like my lecture? Do you have eyes on your back?
All the tables are on
Evans, you understand it?
I have been so busy putting the one thing.
Oh, you guys do not pay attention.
Well, I'm taking this your code that doesn't want to copy over right, and I'm typing it out.
We'll come back to that code. Okay, but think about this. Okay, I'm going to post the slide, I mean my lecture video, so that what? Watch it. Okay. Any portion that you do not follow in class, then watch that portion repeatedly until you understand. Then you'll be a billionaire, believe it or not. Okay, so another calculation here. We need to have errors. Error needs to be error and delta, so-called. So error is nothing but, for example, this is your another level, and this is your ideal output. So that there is some distance between ideal output and your computation, the first iteration computation. Then that much errors. Okay, so that error needs to be. This is error. This is nothing but that. Error needs to be a little bit tweaked by the function. This is a function. Remember the function? This is a function. Whatever we have here needs to be computed. An activation function that needs to be multiplied, right? So that function, in our case, gradient. I'm going to use a gradient. Okay? This L1 error needs to be plugged in this formula, and then we multiply these two together. That will be the delta function, delta. So we have error and delta, two computations to be used. Okay, now the coding. This is a gradient, sigma. Oops, where is it?
Because
So here,
two different codes on this one and the next one, right?
no, the same code. Oops, why my mouse? Where am I? Right here. So here. Okay. Here, this is gradient. Okay, this is a little bit of, this is a function, right? From here there. There's a function. If it describes the second argument, this function takes two arguments. If the second argument specifies true, then we compute this. If the second argument is not specified true, but something else, or empty, then this is a gradient. This is a gradient. What gradient means is that if we have errors, we have very high errors, small errors, whatever the errors. So we need to find out the trend of that error. Trend. So take that trend into account. Trend is nothing but, in our case, it's a gradient. Gradient. And there is a gradient formula. That's a function already defined, which is 1 over 1 plus natural base and negative whatever the value. If that is x, then x. We call this as a g of x, some gradient. Okay? This is function. And then we have one for loop from here all the way down here. and we give input. Input is X, and output, our ideal output is this. Remember that our ideal output 0, 1, 1, 0, 0, 1, 1. This is the example that I used. This is the input data 0, 0, 1, 0, 1, 0, 1, 0, 1. I have 7 data sets. So we have X and Y, and then this is the seed number. This is random number generator. Remember that we have 2 times random number, 3, 1, so that we have 3 inputs, 2 inputs and 1 bias. That times 2 and minus 1 to make our weight to be generated between -1 and 1. So that is generated. Okay, this is nothing but weight, WI. And in the for loop, I want to iterate 6,000 times. Initially, input is X, so that we have 2 inputs and 1 bias. So this is bias 1, this is input 1, and input 2. They are all represented by X, Y, X, Y. How? X is represented in that way. 3 numbers together in one transaction. And this is in the middle, I1. By production, which means if I have here and there, if we have weight 1, which is sig 0, and I1, that is the input. So input number and weight, we need to multiply that. But we do vector so that there is a vector multiplication. You know that dot production, right? Dot production in array or matrix in mathematics. Remember that in scalar production was a dot product in math? Ellen, do you remember? In high school math, algebra, as a matrix, and dot products.
Don't remember that.
Hmm?
Don't remember that.
Don't remember?
I don't think you learned that.
What about here our guys, Chinese guys? Do you remember dot products?
I don't know.
You may have different language. What about? You have double E major.
So it's you plus and multiply column
Yeah.
added.
Dot product is this. Where's my? Okay, here. If I have here, yeah, explain. Oh, I have a good tutor. Very good. That's dot products. So if you do not do that manually, program it. Simply, what is the language? Simply dot. If you say dot, then you can handle it. So it returns the middle neuron here. So you have another neuron. How many times? 6,000 times over neurons. That's what this program is making. So we call that deep learning. You can do that 60,000. You can practice 6 times. Or we can practice 1 time. See how it works, okay? So that we can increase the iteration. Alright, this is an error. The first error. This is the ideal outcome. This is the outcome that I just make. This is the value. Whatever the value here, that may be far from my ideal. So that much, that is an error. With that error, I have here gradient. Remember that? If I say true, then it returns this. If not true, then gradient. But in this case, you can try false, but in this case, let's try to true. This is less accurate. If you make gradient operations, gradients activation function, then you might have different result. And after that, we need to update the weight, update the weight by dot products given IO and delta. So we make new operation, new weights. So new weights can be, this is it's a little bit of a trick, but let's use this as is, okay? After we complete the whole iteration, then finally we can print I1. Then we can see how I1 is evolved from the given X. This is given X. Given X here. How this guy evolves, finally we have this. That's what I want to work together with you. Okay? So let's do.
In error when I'm running this,
Okay.
that x equals np array line, the first one, that one's being reported back as a type error. List indices must be integers or slices, not tuple.
I don't know what you.
I don't know what we did.
Where?
The 001, 010.
Oh, that must. You have to make sure that it's clear. This is right format.
I put it in, yeah.
Look at my code. Okay. So I'm going to discard this, and I'm going to bring up my Python. Okay, here my Python. Which one that I? That one? Where am I? Here. Okay. Maybe this? Or not this? Yeah, this is it. Can you make this? 1, 2, 3, 4, 5, 6, 7. Yeah, this is exactly the code that you may be able to. You need to first import num_p. There's a number, the modules that handles numbers. So we make it np for simplicity. And all others, for example, I made some print statements so that if we have dot t, so you would see transposed y. Y is I made in one row, right? But if you transpose it, then you might have 7 rows. So that you have 7 rows like this. If you do not like this, then you simply type in this way. If you do this way, that is the same as array 0, comma, and then say here 1, comma, whatever you do, you continually do this, and at the end of that, then that is the same as you simply type 0, comma, 1, comma, so on and so forth, and close square bracket, another close square bracket, and close parenthesis, dot t. Dot t will make your array transposed. So we can practice it here. For example, import num p as np, and then you can do y equals np dot array, and then you can do 1, 2, 3. Okay, then y is that. What about y dot t? Y dot t is that. Do you see what I'm saying? Y is simply 1, 2, 3. But if you do y dot t, it transposes. That's the beauty of Python. So array or matrix manipulation is very powerful. That we use here. Another random number generation here. So we can practice that also. Here, if I want to do np dot random, and if I say nothing, that it returns that number. If I do that, then another number, and another number, and another number. All the numbers that a function generates are between 0 and 1. Between 0 and 1. But if you want to make that greater than -1 and less than +1, then you need to make this. -1, then it returns -0.8, -1.14, and +0.3, and +0.7, and -0.2. So that returns random number between -1 and 1.
On line 35 and 36, what is that?
Where?
By 0 and 1, what's in front of it? 35
Where?
and 36, line 35.
Oh, line 35, 36.
Yes, sir.
This is the input, right?
Yeah, but
I'll call it first level of nodes, L0. This is not I0, L0. I want to compute L1, one deeper level. How can I compute based upon L1? I need to multiply the value in the node L1 with the weight W. So weight is that's a sigma. Okay. we call this thing, or synapse. We call this simply synapse. SYN0 means synapse. What is a synapse in biology? I mean, the neurology. It has, if you were neurons and synapse, neurons send the data through synapse. So synapse is nothing but weight that we compute. This is a way that we compute synapse. But randomly, we don't really compute manually here. All randomly. So, and then for loop, if you try that, let's say 1 time, 2 times, okay, and save it. If I run it, what happens here is that here this is output, okay. When I said the input 0 exclusive over 0 means 1. This is my training set, but that is not. So it already dropped to 0.3. But instead, 0 exclusive 1 means 1, but in my bias I call it 0. So already it's increased, right? So somehow it thrown to the proper ideal case. But if I train them, for example, 5,000 times, 5,000 iteration, see what happens. If I train that 5,000, then the first one is close to 7, second one, is it the case? First one is close to 7. 0, 0 is not true yet, right? It depends, right? If I make 10,000, somehow it is not really well trained. But 0, right, somehow.
Is the output need to compare with Y or should be compared with X? Because if your output is like 7 data, right?
The ideal is 7 data, yeah.
So it should be compared with Y or it should be compared with X? Because X.
No, compare with the.
Compare with X.
We know. Compare with X, because this is the input 0, 0. Then output, ideal output is 0, right? But is biased by 1. That's how it works. So if we change this to, for example, all the bias is 1 rather than 0, that is the theory. Let's see what happens. It's a little different. This guy says this is right? This two cases right. 1 1 returns 0, 1 1 returns 0. That is correct. So 1 0 returns 1. That is correct. But somehow it is not really well trained. But this is the way that a neural network works. And another example that I made, the last slide of yours, I'm going to give you let's see if we have. I'm going to give you a demo and okay. I'm going to give you a demo and then I'll stop today's lesson. What happens here is that in any sequence, let's say you have a sequence 0.1, 0.2, 0.3, 0.5, 0.6, 0.7, then it increases 0.7 and then 0.8, 0.9, and things like that, right? Assume that we have a series of linear data sets. Okay, linear data sets. So my first training set, what happens here is that, I'm going to explain that, how I practiced it. Here, I have, it doesn't matter, whatever the number that I have, say I have this kind of a number, okay? And then I would say this is some stock values, 45.99, okay? And next value is whatever that. Let's say next day it increased 55, which is so good. And then next day it dropped, for example, 35. Doesn't matter. We have some numbers. But to normalize that, I make only the ratio, change ratio. So how many percent changes from here to there and from there to here. So I have somehow 20% change, then there's 0.2. 30% change, then 0.3. And 10% dropped, then there's negative 0.1. So everything can be written in negative 1 and 1. Given any data, doesn't matter the magnitude, but if you take the data from that magnitude, only the ratio, change ratio, then it falls in that category, negative 1 to 1, right? Given any kinds of value, it'll fall into negative 1 and 1. That is the case here, so that I can consider first 3 days of stock price, and then I assume the fourth day. Again, second, third, and fourth day, I can assume fifth day, and third, fourth, fifth day, I assume seventh day, but this is biased. So biased, I have some values correct, some values biased, right? So all biased data. The last value each listed here is biased. So it is not correct. 0.4, 0.5, 0.1. Actually, according to my synthesized data, it should be 0.6. But 0.3, 4, 5, 0.6, oh, that is what I want. 0.3, 0.4, 0.5, 0.6, oh, this is what I want. 0.4, 0.5, 0.6, and 0.1 bias. 0.5, 0.6, 0.4, 5, 6, and 0.7. 0.4, 5, 6, 7, oh, that is correct. 0.4, 5, 6, 5, 6, 7, 8, oh, that is good. But anyway, the last one, that is biased. And then this is ideal. If we have first 3 data, then I know that fourth data is 0.4. If I have 0.2, 3, 4, then fourth data is 0.5, 0.6, 0.6, 0.6, 0.7, 0.7, 0.7, 0.8. This is ideal. Okay? The exact same algorithm, same neural network that I used, right? But a little bit difference here is that I have 2 different kinds of weights, and those are used. So I wanted to take a look at that. But how many iteration? I have here 90,000 iteration. See what happens. If I run that, these are errors. how many errors. So I have here, for example, if I have 0, 1, 2, 3, the next value will be 0.49999. And if I have 0.2, 0.3, 0.4, next value will be, oh here, I started from wrong. This is almost 0.4. This is almost 0.5. Next 3, almost 0.6. Next 3, almost 0.7. And the last, 0.8. That's what those are the ideal values. But according to train, if I make that many iteration, these numbers converge to that ideals, which is learning. Okay? So I wanted to practice that at home. If we have this kind of values, then your coding is the same as mine. All right? Any question? So this is deep learning, so-called artificial neural network. You have to think the application of this very carefully, so that if you have a series of data, for example, series of attack and malicious intrusion, then having the first 3 or 4, and then you have the data, right? You have the real data, so that what will come after first 4 data or 5 data. So pick first 4, pick next 4, and next 4, and like I picked, right? And practice and learn, and let it learn. Not your learning, but system learning. That's called the machine learning. Okay. This is what I want to say to you today. All right. Any question? If you don't, I wish you have a great Thanksgiving with delicious turkey.